Okay, so let's answer this one also using the trig substitution. So the few things that you've seen already is you know that it's very essential that you basically get to familiarize yourself with this identity, sine squared of theta plus cosine squared of theta. It's very useful as you basically deal with integration by trig substitution. Okay, so now in this case, let's try to pay attention to the radical we have. So root of x squared plus 4. So thinking of the same identity that I've just written there, sine squared of theta plus cosine squared of theta. Which form of that equation, or that identity, can this be? Okay, so you notice that it basically gives us the identity where we have tan, right? So if you divide the entire equation by cosine theta there, you're going to have tan squared of theta plus a1 equal to secant square of theta, right? So therefore, since it's tan, that is at the same position with x, so we're going to use tan for substitution here. So let our x be equal to, remember we've been saying it's a over b, right? So a over b, and then tan what? So that's going to be tan theta in this case. So if a few things that I've highlighted, I've said that b is basically the value attached to x, and then a is the one away from from x. Okay, so in this case we just have 1 as a coefficient of x squared. Now remember, everything is supposed to be in the form of squares, right? So the basic form is actually, so in this case it's like bx squared plus s squared. So expressing the radical we have, so it's going to be 1x squared plus 2 squared, and then therefore our value of x becomes what? A over b. Our a in this case is 2 and our b is just a 1, so it means we have 2 tan of theta. As simple as that is. Okay, so now from this point I think you should be able to answer the question, so feel free to pause the video and answer it. Okay, so if we look at what we have in our question, we need x squared. Okay, so x squared becomes 4 tan squared of theta. So that's what we're going to substitute in the brackets. At this point, I think let me try to approach the question in a different way. So the square root therefore we have is x squared. So for x squared we found 4 tan squared of theta, and then plus a 4, right? So as you can see, 4 is common, right? So we can factor out the 4. So we have a 4, and then we remain with tan square of theta plus a 1. So we have a square root of that. So the square root of 4 can be found, so that we have a 2, and then it's pulled out away from the square root. Now this identity again is something that you should be very familiar with. Tan square of theta plus 1. I'm just from mentioning it. Okay, this comes in a scenario where you divide by cosine square of theta, so it's going to be equal to secant square of theta, right? So we have secant squared of theta. Okay, and then of course for the sake of this indefinite integral, we just consider the positive result, so that we just have 2 secant of theta. So therefore I can now substitute. So the integral of 1, don't forget our x squared, so we have our x squared outside there. Now x squared is equal to that. So we have 4 tan square of theta, and then under the square root part we found that it's equal to 2 secant of theta. So 2 secant of theta, and then of course we're dealing with dx. Okay, so I can remove this part of simplifying the square root. So let's try to find the value for dx so that we come up with d theta, right? And then I can just remove that part. So what's the derivative of x? The derivative of x is going to be 2. Okay, so whenever we're dealing with the derivative of tan theta, it's secant squared of theta, so it's going to be 2 secant squared of theta in respect to theta, of course. So therefore substitute that. So we have the integral of 1 over 4 tan square of theta multiplied by 2 secant of theta, and then we can try to substitute 2 secant squared of theta d theta. So since we've got 2 there squared, and then on the bottom we just have 1, we can actually get to cancel out, right? So let me write one more step on the bottom here. So the second will just go, okay, and then the 2, so this 2 can divide by that 2, and then the second can also divide, so that we just remain with a single secant on top. So we're going to remain with secant of theta on top, and then on the bottom we're just remaining with 4 tan squared theta, okay, and then the theta there. So I know that my tan squared of theta is, since I know that tan theta is equal to sine squared of theta plus cosine squared of theta, of course if I square. So in such a case, since in this case it's like the reciprocal, since it's on the bottom, I would have to swap it. So we're going to have something like, this is the same as multiplying now the secant of theta multiplied by, so where we have tan theta there, tan squared of theta, it's as good as saying we are dividing by tan squared of theta. Now dividing is the same as multiplying by reciprocal. So the reciprocal is therefore going to be cosine squared of theta over sine squared of theta in respect to what? To the theta. Now if you look at secant of theta, if you know, secant of theta is the same as 1 over what? 1 over cosine of theta. So at that point you see that one of these is going to cancel, so that we just remain with cosine of theta here. So what are we remaining with now? So we're remaining with the integral of cosine of theta, and then on the bottom we just have like sine squared of theta, and then we have d theta there. Let's not forget about the 4 which is there, so we can just put it out of the integral at this point so that it can continue being outside there. So at this point, how basically can we integrate what we have? So if you look at what we have here, we can basically handle it by u substitution, so that we can just do away with what is on the top part there. So we have 1 over 4, and then the integral of, so let our u be equal to sine theta, so that our du, which is the derivative, can basically be, what is the derivative of sine? It's cosine of theta, right? So that's in respect to theta, so d theta there. We can make our derivative of theta to be the subject, so we're going to end up dividing our du by cosine of theta, and then we can substitute on the next stage. So top part, what we have, so we have cosine of theta over, now sine squared of theta, we're saying let our u be equal to this, so it's going to be u squared, since we have u being equal to sine theta, and then derivative of theta is basically this, so du and then cosine of theta. So don't forget that our u is equal to sine of theta, okay? And then that is going to divide, so that we just remain with the integral of 1 over u squared du. Okay, so we can easily integrate that by just adding so we can have it 1 over 4, and then we can just have u being as a numerator, so power becomes a negative when it becomes a numerator from the bottom. And then the next step we can just now integrate, so we're going to have u, and then we'll add a 1 to the power, divide by the same result, which is of course negative 1, and then plus a constant c. So what's the derivative of that? So we're going to have 1 over 4 being maintained, and then for our u, negative 2 plus 1 is just going to be a negative power, divided by a negative, we'll have negative 1 over 4 now, plus a constant c. We can still make it better, we can have negative 1 over 4. Let me continue from this other side. We can have negative 1 over 4, and then u can go to the bottom and become positive, so negative 1 over 4u in a better form. Negative, let me remove this part, so negative 1 over 4u, and then plus c. Now don't forget that that is the same as negative 1 over our u is sine theta, so negative 1 over 4 sine of theta plus constant c. So we have to take this back to where we started from, right, in terms of x. So let's come up with a triangle. So for a triangle, we need to go back to what we said. We said let our x be equal to what? So if you remembered, it was in form of tan, and it was a b, right? So it was 2 tan theta. So if you try to make tan theta the subject, you're going to have x over 2 being equal to tan theta. So tan, of course, from Zocatoa is opposite of adjacent. So we were able to come up with a right angled triangle with just that. Pythagoras theorem will help us find the missing side, which is obviously the hypotenuse in this case. Okay, so taking this side to be our theta, our opposite becomes x, and then our adjacent becomes the 2 there, right? So what's the hypotenuse? The hypotenuse is going to be the summation of these two sides squares, so it's going to be x squared plus a 4, of course the square root of it from Pythagoras theorem. So if we check our answer there, we've got sine. So sine theta, according to Zocatoa, is opposite over hypotenuse. So our opposite is x, and then our hypotenuse is the root of x squared plus 4, right? Now, since in our question it's on the denominator part, so we just have like 1 over, so it's like the reciprocal of sine theta. So it means what's on the bottom becomes the top part. So we're going to have negative 1 over 4 first of all, and then since we have 1 over sine theta plus c, it's going to be the reciprocal. So we're going to have negative 1 over 4, and then since it's 1 over sine theta, it's going to be reciprocal, so we're going to have x squared plus 4 on top, and then x on the bottom, and then plus constant c, which can then simplify to negative root of x squared plus 4 over 4x, and then plus constant c.